Hey, welcome to lesson chapter 2. I'm just going to do a quick review of what you see on the filled out lesson. So chapter 2 is sampling techniques. The following sampling methods are all examples of what we call probability sampling methods. The sample is selected at random. Notice that for probability sampling, all members of the population have an equal chance of being selected. Random sampling, remember, it's not remember because you don't know it yet. Random sampling reduces the potential for bias, discussed in what we will be discussing in 2.5. So simple random sampling, that is when a sample is chosen from the entire population, like using a place like random.org, using a random number generator. Each member of the population has an equal chance of being selected. The selection of any particular individual does not affect the chances of any other individual being chosen. Okay, so that's the simplest and best type of sampling. It's like, assigning, if you want to sample at St. Robert's, you would assign each student a number between 1 and 1800 or 1500, and then you would randomly select 100 numbers from the student numbers. Now, the next type of sampling is something called systematic, because simple random sampling is often too expensive and time-consuming to use. So systematic sampling is when we have a random start using a random number generator, and then the sample is chosen by going through the population sequentially, with the members in the sample being selected at regular intervals. The only formula you need to know here is sampling interview equals population size divided by sample size. So here's an example. Let's say we wanted to sample 20,000 widgets coming off an assembly line, and we wanted to sample 100 of this population of 20,000. So our sampling interval would be 20,000 divided by 100, or 200. Now, so we're going to sample 200 widgets. The trouble is you can't just take the first 200 because it will be not random. So to introduce randomness, you must select a random number between 1 and 200 using random.org. Let's say you got the number 21. So then your sample would be 21, and then 21 plus the 200, or you'd sample 221 plus another 200, 421 plus another 200, 621, etc. It's like an arithmetic sequence. The next type of sampling is stratified, because systematic doesn't work in all cases, and it wouldn't work for sampling people in a neighborhood. So another type of sampling is called stratified. Again, it is random sampling. Here you divide the population into groups. The groups are called strata. Each of these groups shares some sort of a common characteristic. This common characteristic is it's determined by when you're actually setting up, when you know the questions that you're surveying. We don't know that, so we're just going to speak in general. From each group or strata, a simple random sample is taken. The size of each sample is proportional to the size of each group. Group members who share common characteristics such as gender, age, education are called strata. Okay, so for example, let's say you wanted to do a survey at St. Robert's, and you've decided that this grade level, people in grade 9 have sort of the same opinions, people in grade 10 over whatever your survey is about. So let's assume that we had 880 people, and we wanted to survey 25% of the student body. Okay, now in a proportional sampling, proportional stratified, you would just take 25% of each group. If you add it up, that gives you a total of 220. Okay, so for example, for the 64 grade 9s, you would randomly generate 255 numbers for each one of the grade 9s, and then you'd randomly pick 64 of them. Maybe you'd use student numbers. That'd be actually probably the best way. Now, by the way, stratified does not have to be proportional, but that's the only type we're going to look at. Now, unfortunately, stratified doesn't always work either. So there's another type of sampling called cluster. With cluster random sampling, you divide the population into groups. However, the groups here are called clusters, not strata. Okay, often a cluster is geographic, like neighborhoods, for instance. Now, in cluster random sampling, you divide the sample into groups or clusters. A random sample of the groups is chosen, and then all members of that group. I'm going to explain this, give you a better example, because stratified and cluster are slightly different. For multi-stage random sampling is, again, you separate the population into groups. You random sample groups, and then from each random sample, you random sample again. So essentially, multi-stage random sampling is just several levels of random sampling. Okay, so you random sample the groups, and then you random sample within the groups. Destructive sampling is never a type of sampling that is standalone. It is always with another type. So for example, for destructive sampling, maybe you do a systematic random sample of an assembly line. You want to test what light bulbs work. So you would do a systematic sample, but then in order to test how long the light bulbs work, you actually have to burn them out. So it's called destructive. Okay, it's pretty obvious. It's never standalone, and obviously you cannot do that with people because you can't kill them. Now, another type of sampling, which is a standalone, is called multi-phase random. Usually multi-phase requires two steps. It involves asking a simple question to narrow down the population. For example, do you smoke? Followed by more detailed questions targeting your restricted sample size. At what age did you start smoking? Now, all of the above that I just talked about were probability sampling. These are the best type of sampling because you can quantify the probability of being selected. However, there are a lot of non-probability sampling methods. These are the ones you're probably really more familiar with. Non-probability sampling is the selection is not random, and it assumes an even distribution of the characteristics within a population. It's kind of like when you're stirring up soup. How many mushrooms are in the soup? Well, if you stir it up really well and you scoop out a cup, if you get 2 mushrooms in that cup, then you have to assume that that's the ratio in the entire rest of the pot of soup. Okay, that's the analogy. I know it's not a very good one, but that's it. Now, volunteer sampling, the researcher invites members of the population to participate in a survey on a volunteer basis. That one I'm sure you're familiar with. You can see it in a shopping mall. Sometimes you'll see it on a radio show. They'll ask you to phone in. Convenience sampling is the researcher selects members of the population that are easy accessible. That's again, you're walking in a mall and they're set up a booth at the entrance to a shopping mall. That's convenience. Judgment sampling is when the people that are experts, they choose the people in the sample. Okay, so the people that are running it, that are the experts, they're the ones that make the choice. Quota sampling is literally what it is. You sample until you've reached a specific quota. For example, maybe you want 10 females and 10 males. Okay, now this table here just lists the different types of sampling methods, advantages and disadvantages. Some of this you don't really need to know. Just read it over once or so. I got these from Stats Canada. So they're all here and here and here, advantages and disadvantages. Now let's go to an example. Let's pretend we were doing a sample at St. Robert and it has 1,440 students. We're going to, in this perfect world, we have 48 homerooms. Each homeroom has exactly 30 students. And there are exactly 12 homerooms per grade. I did this just to make the calculations easier. Describe how you would use each of the following sampling methods to sample 120 students. Okay, well, simple random's easy. You would just number the students from 1 to 1440. Then you'd randomly generate 120 numbers using random.org. Okay, that's pretty obvious. You would probably actually end up using their student numbers. Now, for systematic, the first thing you need to do is to create the sampling interval. So you take the population size divided by the sample size. So you're going to select every 12th person. Now, we have to have a random start though. Oh, by the way, you have to number them from 1 to 1440 also. Then you need a random start. So you randomly select a number between 1 and 12. Let's say you got 7. And then you would sample the 7th person, the 7th student number, the 19th student number, the 31st, etc. That's just one way. Now, stratified. Let's say we decided to stratify by grade. Now, in this perfect example, each grade will have 360 students because 1440 divided by 4 is 360. Or you could say that there's 12 homerooms in each grade times 30. So then what you would do for stratified is you'd randomly sample 30 students per grade because you've got 4 grades, 120 divided by 4, 30 students a grade, okay? Obviously, also there you would need the student numbers from 1 to 1440. Now for cluster, for variety, rather than using a grade as a cluster, we're going to use a homeroom as a cluster. Now remember, there are 48 homerooms. You would number them from 1 to 48. Now you would randomly select 4 homerooms, because remember, there's 30 kids in a homeroom. And you need 120 people in your sample, okay? So you'd randomly select 4 numbers between 1 and 48, which would give you the 4 homerooms. But then you would survey everyone in those selected homerooms. That's the difference between cluster and stratified. In stratified, you select a portion of each group. With cluster, you only pick certain groups and you survey everyone in that group. Multi-stage, let's assume your group is homerooms. You would randomly pick, let's say, 12 homerooms, and then you'd randomly pick 10 people per homeroom. 12 times 10 is 120. Obviously, you could have picked 6 homerooms and 20 students. For convenience, you just survey the first 120 people that walk into the CAF during lunch aid. Okay. A second example, a survey of students living in a high-rise residence is conducted. The residence has 10 floors, 20 rooms per floor, and 2 people per room. What type of sampling interval selects every 40th person where people are ordered by their location in the building? Well, I think you can see that that's systematic because that's the regular interval. What type of sampling method is used if 2 floors are randomly selected and every student on that floor is surveyed? Okay, so each floor is a cluster, and notice you're sampling everyone, so it's cluster, not stratified. Now here we have 2 floors are randomly selected, and then both of the residents of 5 randomly chosen rooms on both of the floors is surveyed. What 2 methods is used? This one's a little trickier. Okay, first it's multi-stage because you randomly select a floor and then you randomly select a room, or actually you randomly select 5 rooms. Then it's also cluster though, because you have to remember that there are 2 people in a room and you're selecting every one of them, both of them. So it's actually multi-stage cluster. Here's the homework right here. Now the next section is bias. There are 4 biases and unintended influence on the data gathering method. There's 4 types of bias: sampling, non-response, household, and response. Non-response is pretty easy. It's when people don't return the survey or don't answer the phone call. Response isn't too bad either. It's when factors in the sampling method like question design, interviewer tone, and attitude influence the result, or when participants in a survey deliberately give false or misleading answers. The ones that are confusing are sampling and household. Okay, sampling bias is when the chosen sample does not accurately represent the population. Household bias is when one type of respondent is over or underestimated, over or underrepresented because groups of different sizes are polled equally. Now, when you first look at that, somebody could say, well, if you overestimate or underestimate a group, aren't you not accurately representing the population? Well, the distinction is here in red. With sampling bias, you leave out an entire groups. With household bias, you misrepresent the number in certain groups.